All right. Hi, everybody. It's Miss Fennell filming from my living room tonight with my cat, Clementine, in the background. We'll see how long she stays there. I don't know. Little distractor. Oh, little distractor. Got another cat going to join in. All right. So I'm here with you today to tell you a little bit more about populations. So we already learned through our Polar Battlefields movie and poster project that a population is a group of the same living things of the same kind living in the same place at the same time. So you can have a population of prairie dogs in your backyard. Clementine's still asleep. You can have the population of prairie dogs in the state of Minnesota. You can have the population of prairie dogs in the United States. So we're going to take a closer look in today's lesson about populations. So I'm going to share this slideshow with you later. There's my cat Dorito walking down my hallway. Distractions. All right. I'm going to share this thing with you, this website called the World Population Clock. And I already clicked into this, so just wanted to show you this. So you will be able to go into this website. I'm going to make my circle a little smaller here. You're going to be able to go into this website. I'm going to share this with you in Schoology. So this is kind of interesting. This is the current estimated world population of humans on planet Earth. And right now we're at about 7,693,265 people and growing. I mean, just look at this counter going. Our human population on the planet is growing all the time. Back when I was a seventh grader, which wasn't that long ago, the population of the world, that's about 30 years ago, I suppose, was 4.6 billion people. We've added 3 billion people in the last 30 years or so. There's crazy estimations of how many people we'll have in another 30 years. The most populated country in the world is China. They have 1.3 billion people. 1.3 of the world's 7.6 billion people are in China. The United States has 329 million. And that's grown by about 30 million just in the last 10 years or so. So populations of humans on planet Earth are definitely growing. Over here, if we take a look at the U.S. population, the U.S. population is growing a little bit slower than the world population is. You can see this counter is moving a lot slower. And if we look at the causes for this, we have one birth in the United States every 8 seconds. So it's kind of funny to watch this. Look at that. Every 8 seconds, somebody's being born. There's another birth. Every 12 seconds, somebody in the United States is dying. So they kind of do a countdown there of death rate in the United States. We get an immigrant every 47 seconds, which adds to our population. So this means between people being born and people dying and people immigrating in, and we have people emigrating out as well, but not as many, we gain one person in the United States approximately every 18 seconds. So every 18 seconds, you'll see this population of people in the United States actually growing. But we can do study populations in terms of humans and people. We can also look at that in terms of wildlife and things like that. So on the next page here, if you have your textbook, there's a little fun part in the textbook here called Prairie Dog Picker Upper, and it's on page 10. There's my cat Theo joining in on the fun. Clementine's still sleeping. All right. Extra entertainment tonight. I don't know if that's distraction or entertainment. All right. On page 10, if you turn to that page, otherwise, if you don't have a paper book, I'll just read the page to you. I think this is kind of a funny story. It's called Prairie Dog Picker Upper. And it's one of my favorite stories in the book. So it says, did you know that vacuum cleaners do more than just clean carpets? Across the Great Plains, farmers are using specially designed vacuum cleaners to help them remove black-tailed prairie dogs from the farmland. Prairie dogs can eat crops, cause soil erosion, and endanger cattle and farm machinery. The Prairie Dog vacuum uses a 4-inch plastic hose to suck prairie dogs out of the ground at 483 kilometers per hour. That's about 240 miles an hour. This is my favorite sentence in the whole ecology book. Are you ready? Are you ready for this? It says, the prairie dogs end up in a padded tank, usually unharmed. Usually. Then they are relocated or donated to the U.S. Fish and Wildlife Service to be fed to endangered eagles, hawks, and black-footed ferrets. So prairie dogs sometimes are pests. It says here because they eat crops, they dig holes. Oh, Clementine's gone. She's going somewhere else. All right, that's fine. Anyway, And so prairie dogs can actually be relocated, and we would call this emigration with an E. We would call this leaving an area, and we'd call that emigration. So the book questions say, if all the prairie dogs were removed, how do you think the prairie ecosystem would be affected? Obviously, anything that prairie dogs eat, their population is going to go up. And any prairie dog predators, so things like eagles and hawks, that sort of thing that eat prairie dogs, their predator population probably would go down. This is just an interesting discussion question. Do you think prairie dogs should be used as food for endangered species? That's just kind of an opinion question. If we're removing them, if they're a pest, is it right to be using them as a food source for endangered animals because there's too many of them here? In many places, we have overpopulations of different creatures. And so we do relocate them to other places. All right. So we already kind of went through this. What is Earth's population of humans? It's over 7 billion. How does the birth rate and a death rate make the population go up and down? If you have more things being born, hatched, or sprouted, this is kind of on my next slide as well. If you have more things being born, hatched, and sprouted than are dying, if your birth rate is higher than your death rate, move myself around here, then your population will grow. And this is shown by a line going up on a population graph. So this little thing right here is a population graph, and we have a population of bears shown in yellow. So their population is going up on this whole graph right here. The dolphin population is in orange, and that population is going down on this population graph. Then we have a population of whales. This is completely made up data. This isn't from anything, but just to kind of show you what a graph looks like here. The whale population went down and then up and then down and then up and then down. And so usually when we make a population graph, we do a line graph. And so then it's very easy to see over the years, we see change over time. We see how the population changed over time. Lines going down mean the population went down. Lines going up mean the population went up. This stuff makes sense, right? And again, if the birth rate, how many creatures are born, hatched, or sprouted, and we can be talking about plants here as well, is higher than the death rate, the population will grow. If the birth rate is less than the death rate, then the population will shrink. And again, that's shown by lines going down on a graph. Populations can also grow or shrink due to immigration, which is individuals moving in to a given area, or emigration, which is individuals moving out of a given area. So these are some of the things that make populations grow and shrink, okay? Imagine, if you will, 7th graders, a rabbit population in a forest, a happy little rabbit population, if you will, living in the forest. What kinds of things, if you could think to yourself for a minute, what kinds of things might make the population go up? What kinds of things might make the population of rabbits go down? All right. So things that might make the rabbit population go up. If you thought of any of these things, you're right. If you have more food available, more food for the rabbits, probably going to get more rabbits. If you have fewer predators for the rabbits, if we have less predators, probably going to get more rabbits. If the weather or climate is nicer for them, usually we're talking here in the winter time, we don't have anything like droughts or forest fires or really harsh cold winters or really snowy winters. Nicer weather for animals like that would make their population do better. Few of them will die, right? So these are all things ultimately that affect the birth rate and the death rate. If you have more food available, your death rate is going to be less, therefore your population will go up. If you have less disease can be a big factor in many populations as well. So less disease makes populations go up as well. Things that might make rabbit population go down are basically the opposite of these. Instead of having more food, if we have less food, our population will go down. If we have more predators for the rabbits introduced to an area, rabbit population will go down. This stuff's pretty much common sense, right? This makes sense to 7th graders. Worse weather, if we get a really super cold winter, that's really harsh on them. If we get a drought in the summertime where they don't have any water, that's really harsh on them. If we get a disease that's introduced that sweeps through our population, of course, that can make our population go down. So these are things that are kind of just common sense, and we can think about populations going up and down. So here's the big question. Is there a limit to how many rabbits can survive in the forest? Is there a limit, do you think, to how many rabbits can survive in any given forest, a rabbit population? Okay. And this is where, this is what I love about seventh graders, you guys. When I've done this in class before, I've had a lot of seventh graders that will tell me, oh, there's room for all the rabbits in the forest. Everybody, all the rabbits who want to live here can survive. And I'm sorry to burst your bubble, optimistic seventh graders, but there is a limit. You cannot have an unlimited number of rabbits survive in a given area. The limit to how many rabbits can survive in an area is called carrying capacity. Carrying capacity is the maximum number of a population that a given environment can support. Within that environment, you only have so many resources. You only have so much food. You only have so much space. You only have so much water. You have so many predators and, all of that kind of thing. So all of these factors, I should have underlined this, it's determined by the limiting factors in that environment. So a common limiting factor for rabbits in a forest would be food. If they run out of food, their population is going to go down. If we have number of predators increasing, rabbit populations are going to go down. If we have bad weather, like I said in the previous slide, if we don't have enough room for nesting sites and things like that, if we have disease, and generally as a population gets bigger, your potential for disease increases. It's easier for them to spread diseases to one another as populations grow. So there is a limit to how many rabbits can survive in a particular area, in a particular forest. And as you reach the carrying capacity, you start to run out of food and water and habitat. And that's what we call our carrying capacity, which is determined by the resources, by the limiting factors in that particular environment. Okay. So if you have your book and you want to look on page 13, this graph is on page 13. And just to explain this graph, we have years on the x-axis here, and we have our rabbit population going up for a period of time and then going down for a period of time. So from year 0 to 4, more rabbits joined the population than left it. We had more of them being born than dying, and so our population goes up. Year 4 right here, all of a sudden, we have more rabbits leaving the population, and so therefore our population numbers are going to go down, okay? So question number 1 here. What year did the rabbit population reach its highest point? By the way, in the Ed puzzle, these 3 questions are going to be the next 3 questions in your Ed puzzle. So if you want to maybe pause the video, I'm going to go over the answers with you, maybe jot them down so you can answer them correctly in the Ed puzzle here. What year did the rabbit population reach its highest point? Well, if we look at the graph here, the highest point of the graph is right here, and that would be in year 4. So year 4 is where our rabbit population reaches its highest point. Number 2, what was the size of the rabbit population this year? People get this a little bit wrong. So our rabbit population, if we go across here, it's somewhere in between, close to between 800 and 900. So it's about at the 850 mark here. But this label tells us it's in the thousands. So the actual top here would be at about 850,000 rabbits. Okay. And then question number 3, what would the carrying capacity for rabbits in this environment be? So our carrying capacity generally is going to be the top of the population graph. So 850,000 rabbits is probably the maximum rabbits that this population or that this environment can support. Once we hit this point in our population, we run into limiting factors that then reduce the population and bring it down again. So that's the highest point. You're going to have in the coming days several population graphs to create and to read. And so once again, we usually make a line graph with years on the x-axis or time on the x-axis and the number of our population on the y-axis. All right. One of my favorite examples are tulips in a field. This is on pages 15 and 16 of your book if you want to look there. Otherwise, you can just look at the picture right here. There is a limit to how many tulips will fit in this field. That's one of my favorite book pages because you just see these rows and rows of tulips. The maximum number that will fit in this field carrying capacity is the carrying capacity. And that applies to plants as well. You can only pack so many plants together before their roots can no longer absorb all the nutrients and things like that. They compete. Plants actually have competition with each other for space and for water and for sunlight. And so the maximum number, again, that will fit in any given area is our carrying capacity. And that is determined by the limiting factors. In this case, the limiting factors for tulips in this field is going to be space. And again, plants, it's a little bit different. Animals, their highest limiting factor is usually food supply. For animals, or for plants, the number one limiting factor is usually space. So this applies, carrying capacity and limiting factors apply to plants as well. All right. Last question. We're on the last slide. I wanted this to take about 15 minutes, and I'm really close here, so that's good. Is there a carrying capacity to how many humans can survive on planet Earth? What are our population's limiting factors here on planet Earth? Do you think there's a limit? We have over 7 billion people on the planet right now. Is there a limit to how many people can survive on planet Earth? And the short answer to that question is yes, there is a limit. Just like rabbits in the forest, we don't have unlimited supplies of resources here on planet Earth. Now, the good thing is we've gotten better and better and better over the years. Our farmers have gotten better at raising more and more food on less and less land. But there is a limit. We can use technology, things like hydroponics, to help grow more food supply for our growing number of people on the planet. We do better with engineering crops and genetically engineering crops and things like that to try to get more plant production off of a smaller area of land. But some of our limiting factors on planet Earth that we have to think about are space. There's only so much space to put houses and things like that. Food supply is a very big concern as our population on the planet grows. Are we going to be able to grow enough food to feed all the people? And then the second part of that is, can we get that food to everybody who needs it? Because that's a concern as well. Weather and climate has a huge factor in how many humans can survive on the planet. And this is one of the reasons we're so concerned about climate change. Climate affects our ability to grow food. And so if in the Midwest here, it gets to be warmer than it normally is, that can affect our growing season for crops, whether we have droughts or whether we have floods, things like that, that can really affect where people can live, and really can affect how much food is growing. We have ice, for example, the ice sheets in Antarctica, the glaciers are melting. Any ice that melts in Antarctica goes into the ocean, and because it's ice that came from land, it will make the ocean levels rise. Now, most of our most populous cities in the whole world are on our coastlines. If you think about the United States, what are our biggest cities? New York, Los Angeles, they're both on the coast. So if ocean levels rise, we're also concerned about the space, and not, we're going to have to move where the major cities are if our ocean levels rise. So weather and climate plays a huge role in how many humans can survive on planet Earth. There's Theo. Pollution and waste production. The more we are processing things, the more we're doing stuff. We produce a lot of garbage. We produce a lot of chemical waste. We produce a lot of things like carbon dioxide. We pollute our atmosphere. We pollute our water supplies. So we could actually poison ourselves to death if we're not careful. So how much pollution we're making could also affect how many humans can survive on planet Earth, and our air quality and, things like that. If we go to some major cities in the United States, places like Beijing in China and certain places in India, the air quality is really bad. Like, it looks hazy there most days. And so if we have lots of people living on the planet, and we don't find cleaner ways to do things, we could have pollution issues. So just looking at how our world population is supposed to keep growing over the next 10, 20, 30 years, a lot of us are kind of looking to science to solve some of these problems. How can we build better buildings so we have enough space for everybody? How can we grow enough food for everybody? How can we do all of those things without creating pollution and waste that, will poison ourselves? How can we do things so that we're not affecting climate change as much? These are all things that we have to think about for our population here on planet Earth. All right. So that is the end of the Ed Puzzle today. Hopefully you got all your questions right. That's it for today. We'll see you guys back here tomorrow. Have a good day.